also get the same marks. Now, the questions, the first two questions, cannot be more simple. Okay. They should not appear in any test or exam in data structure course, actually. Too trivial, actually. But what happens is that to most students, if you are not given the function interface, you don't know what to do. The question says that you are asked to write a C function. Okay, there are numerous examples in the notes and also the tutorial exercise that you have done. But many of you just don't know what to do. Now, to find out the largest number in an array, it already in the notes I repeated several times. Many of you like the special value 0. 0 is not a special value. 0 is just a one of the integer value. You are asked to find the maximum in an array of integers. It is wrong results if all numbers in the array are negative. If you set max to 0 at the beginning, no other values in the array can be greater than 0. Don't take zeros as a magic number that fit all purpose. Now in the notes, we have the examples. Instead of finding the maximum, we find the minimum. We take the first number as the current minimum, not assuming that it is zeros or whatever values. The same for finding the maximum. Now the next example is that if we don't want to find the value of the smallest number, but instead find the position of the smallest value, you simply change the usage of the variable mean as the index. Now in the answer for this part, you are asked to find the largest value, remove it. There are still many students give me answers that are ridiculous, but very likely they are not here. Okay. Many of you like to have statements. Then, by this statement, you delete a value. So what is now? If you are so used to writing script language, programming script language, sorry, you misunderstand the meaning of null in the C language. This statement simply says that you put a 0 to the array entries. To remove an element in an array, it is not just you set some entries to 0, then it means that you remove it. Some students just write delete. You know that is ridiculous. It's hopeless. Now in the function, when you say that some values are logically removed, okay, in this part of the notes it explains to you very clearly what is the meaning of removing a value from an array. And actually, you have done an exercise, one of the tutorials, okay, concerning this kind of operations. Those students get very poor marks, they get good marks in their assignments. Two possibilities. Either they copy the assignments. The other possibility is somehow they find a program and submit it, but not their own effort. I can't imagine that if students can't solve problems like this, can deserve a pass grade. It will make your degree with no value. Just imagine, some of you graduates get a pass grade in this kind of courses, and some employers hire you and ask you to write some programs, and you mess up everything. Then it will affect other students that receive a degree from this department. Now, to remove an element in an array, okay, means that you pack all the remaining elements towards the left-hand side of the array, and then you adjust the value of the length of the array n. Okay, so by adjusting this value, then you are telling the computer system that those values at index greater than or equals to n are not weighted data values in your program. Okay. So if you are having requirements to modify the value n in your function, then n must be passed by reference. It cannot be passed by value. Some students give an answer that the value n is passed by address. It's alright, provided in the other part of your statement you have your programs written in a consistent manner. Then your answer is correct. Okay. So if you are not giving a consistent answer, then it's incorrect. Now you see that this is a very simple answer expected from you. Many of you, no matter what array is given to you, the first thing you do is sort it. Okay, some students memorize the programs, either the bubble sort, insertion sort, sort the array, but can't give me the proper function interface for that questions. Okay, everything becomes main, bubble sort, and so on. Now the second question, to compute the average, I should not let the external examiner to see this test paper. I may lose my job. Now to compute the average, okay, of a list of integers. Now what will be the average value of 2 and 3? The average value of 2 and 3 is 2.5. Now 2.5 is not an integer. So your returned value cannot be an integer. It must be either a float or double. And the parameters that you need to provide to your function is a pointer that points to the first node in the linked list. Okay. Now within the function, you need the variables to compute the sum of the values, and you count the number of items in order to compute the average. Very surprisingly, a few students don't know how to compute the average. Not even doing arithmetics. For primary students can do it, but somehow some of you can't do it. You give a wrong equation for computing the average. Now to traverse the list, we use a pointer variable. Quite a number of you define your variables, create a node. I don't know why you always like to create a node. But one after you create a node, you don't reference it anymore, and then you set P to point to this. You create a node only if you are changing the structure of the linked list and adding something new to the linked list, then you create a node. You define a variable, you give it a weighted address by assigning to it a weighted value. You don't need to create a node, and then you don't reference it. Now to go through the list, use the typical while statement. As long as P is not a null pointer, many students give the statement like this: if the data is not null. I don't know why many of you are confused about what is a pointer and what is a data value. Okay, for any data value, there's the null constants is not relevant. Okay, so this statement makes no sense in the C language. Now, as long as P is not a null pointer, it is pointing to a weighted node in the linked list, then you can sum up the info, increment the count, and then you move on to the next node. Okay. Now, after you terminate the while loop, you need to check if count is non-zero. If count is 0 and you try to do this division, your program will crash due to the divide by 0 exception. Now, many of you will define this variable sum as integer. If you define it as integer, fine. But if you do the division this way, it is an integer division. So you have the truncation errors. So if you want to avoid that truncation errors, before you do your divisions, you typecast either sum or count to double or float. Then you carry out the divisions, and the CPU will use the floating point division circuit to do the division. So in either way, either you define sum as a double, then you don't need that typecast. If you define sum as an integer, then you need to do the typecast before the division operation. Now the next part, okay, conceptually the same as the first questions. Remove the largest number in the linked list. Some of you have a very strange idea. Okay, concerning about that there are multiple copies of the same number. Okay. But in fact, the setup of the question is to make your life easier, saying that, okay, we have a set of integers. So what is a set? In a set, there's no duplicate elements. This is the basic set theory. Now, to remove the largest element in a linked list, now suppose the largest element is positioned, okay, in a given node. There are two cases that you need to consider. That node can be somewhere, okay, in the linked list, not in the first node. Okay. The other case is that, okay, the max node is, okay, the first node. Now you need a pointer that tells you where is this node containing the largest value. Now to remove a node in a linked list, you need to know his predecessor, right? So that's why when you traverse the linked list to locate the largest value, you need two variables. Okay, the max pointer and his predecessor. Where is his predecessor? Now, if the first node is removed, okay, so if the first node is removed, then what happened to the variable list? It must be updated. To it points to the next node. Okay. So it means that within that function, the parameter list may be updated. And you want this change to be observable, okay, in the calling function. So that's why list should be passed by reference. Note star is the data type of list. Okay. Some of you mix up these two symbols, put them in reverse order. So this is not correct. Okay, wait. Now, to find out the largest element in the linked list, okay, basically you traverse the list, okay, with some pointer variables. Once again, we take the first node as the current maximum. Okay, and it does not have a predecessor. Then we start the traversal of the remaining parts of the linked list. So P can start from length of list. Now why we can do this? Because of this P condition. You are given that the linked list cannot be empty. When you ask the questions, what is the largest, remove the largest value in a set, okay, then the set cannot be empty when you execute this action. Okay? So we are given that list cannot be a null value. Then you can initialize P to length of list. And Q is his predecessor. Then you move down the linked list with the while loop. As long as P is not a null pointer, and I don't know why many students, instead of checking P is not a null pointer, length of P is not a null pointer. There are two different things that you are checking. So P is currently pointing at the node, and then in order for you to make comparison with P, you require that P has a successor, then I make a comparison with P. So this is, I can't understand how you, your logic. Now as long as P is not a null pointer, you compare the data value of P with the data value of the current max node that you have seen so far. If it has a larger value, then you update max as well as the predecessor of max. Okay, so every time you update max, you update max and its predecessor. Then you move on to the next node. So after you stop this while loop, you find out if max is the first node in the linked list. This test can be replaced by testing if R is a null pointer. It's the same. If it's the first node, okay, update list. Okay, now this is updated to point to, okay, the second node. Otherwise, the length of R is updated to point to the successor of max. Then you remember the value of max, delete the node, and return the value. Now, in case if some of you cannot write any meaningful program without the computer do the testing for you, then you have a big troubles in the test and exam. Okay. You may argue, if I'm given a computer, I work it at home, I can give you a correct answer in a few hours, eventually. After the program crashed many times, eventually I give you a correct answer. I know how to solve that problem, but I just can't do it using paper and pen in test and exam. Do I worth a pass grade? Now this is a difficult question. If I'm an employer, I won't hire you. Okay? For simple program like this, it takes hours, and the program crashes many times before you come up with something that may eventually work. So if the problems that you need to solve is a bit more complex, you tell me that you have written up some programs. How can I trust that your programs is correct, can be used? Difficult, right? It's a difficult decision. Well, there may be some difference between the current generation and my generation. Okay, when I first learned how to write programs in my time, I still see some machines around that you have never seen before. It's called the punch card machine. Have you heard about this punch card? No? In the very early days, computers don't have a text editor or a monitor and a keyboard. Okay, for programmers to enter the program, he needs to take a special paper that is printed as a card, 80 columns. Okay, goes to the punch machine, set the pins, punch the card with some holes. Okay, and then every card represents one line of statements that you are trying to write. Okay, and in your program you have a collection of cards in certain order. Okay, now to enter the program into the computer, you take your stack of punch card to a card reader machine, just like currently you go to the teller, a bank. Okay, they have a machine to count the paper bills. Okay, how many paper bills you have? Okay, so you put that stack of cards in the machine, press the button, and then it's the cards pass through the machine, and then the machine reads the content in your cards, and it corresponds to your program. So if you want to make a change to your program, don't let your stack of cards fall on the ground. It will all mess up. Okay? So if you want to change one statement, you punch another card, slip it into the position correctly, and then you take the machine and go through it. Okay. I haven't used it, but I saw it around. The machine is still around. Okay. So by that time, what it means is that if the programmer are going to write a program, you write it on paper, make sure that the program is correct before you go to make your punch cards. Otherwise, you spend hours or days doing nothing. Okay, so the programmer must be very careful in writing the program. Okay, before the program is entered into the computer, make sure that the program is correct. Not say I arbitrarily write something and then, okay, press the button, go. No. Okay, so the training is different. So today's is too convenient. That students never think when they write. Just arbitrarily type something into the computers. Okay, so in this way, you don't change your logical thinking vigorously. Okay, so you write the course too casually. That's why when you get into some trouble, you don't understand why. That is the problem. Now, question 3. Many students doesn't seem to comprehend the requirements of this question. Now you are given an array of transactions. Okay, every transaction is a record saying that on a given date, a given card holder spent certain amount of money. Okay, and the problem that you are asked to solve. Okay, the company want to find out that in a given month, when we say a given month, it is understood that the month of a given year. Okay, if somebody asks you, okay, what is your day of birth? You won't just say that my day of birth is 10th. 10th of what? 10th of which month and which year? Okay. So it is common sense. Okay, when people say a particular day, then it's a certain year, certain month, and certain day. Okay, when they say certain month, then it's understood that it is a month of a given year. Okay, now in the function interface, the year and month are specified. Okay. Now, what you want to find out is that in your array of transactions, you want to find out which card spends the largest amount in a given month. So how are you going to solve that problem? So first of all, if you want to compute the total amount spent by a given card, you want the transaction of the same card to be placed in consecutive position in the array, then it makes your jobs a lot easier. Okay? Now, and you are only concerned about the transactions of a given month, then what should be the sorting order that you are going to use? Now, the sorting order to be used for the sorting is that, okay, this is now if in the sorting order we are only concerned about the data of a given month, then we will first sort the array by year, and then by month, and then by card. Okay, so all the records will be ordered by year, month, and then for all the transactions in the given year and month, they will be ordered by the card number. Now in the function that you are going to implement, the first step, well, the texts are taken from a Word file, and that's why it is some characters not recognized. Okay. Now, the first step you do is to do the sorting using QSort. To use QSort, you note what is the requirements of the compare function and what are the other parameters. And I don't know why. Many of you say this will be cut expense. It is not the proper data type because it already in the function interface tells you that this is an array of transactions. Now after you sort the array by year, month, and then cut, you don't want to go through the array for transactions that are not belonging to the given year and month. Okay, you don't want to go through the array from the beginning all the way, right? Okay, so you can locate the records that belongs to a given year and month using bsearch. Now to do the bsearch, you need to provide the address of a search key of the same type. Okay. Now in the bsearch function, okay, we set up the value of key, and then we have another compare function. Now this time, we are only comparing year and month because we don't know anything about the card. Okay? We sort the array by year, month, and then card. Okay, now what we only want to do is to find out, okay, one of the records belonging to the given year and month. Now the returned value of bsearch is a pointer, is a void pointer. Before you use it, you need to do a type class. Type class is to a pointer of transaction. Okay. Now if the returned value is a null pointer, okay. If it's a null pointer, it means that, well, that you have no record, okay, related to that year and month. Then you, okay, don't find anything. Okay, then you return. Now, if it is not a null pointer, what you want to find out will be the index of the first record with the given year and month. Okay. So we use a variable k. Now you can set this to p minus list. It's fine. Okay. If you set it this, then this while loop simply do one more iteration because the first time you are comparing key with the record that returned by bsearch. That's fine if you don't do the subtract one. Okay. So to make the comparisons, you don't need to repeat writing, okay, to test if the year and month are equal and blah 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 and so on. You simply use the compare function. Okay, but the syntax requirement is that you pass the address of the two records to the compare functions for comparison.
So the bsearch function returns the index of the last element?
No, not necessary. Any.
We go back to the first.
And you use this loop. Well, because in the question it says, it tells you to use Q sort and B search. I don't expect you to write whatever, your own binary search. Now, when the loop stops, the index K will be pointing to the record before the first record for the given year and month. Okay? Then you need to add back 1 to it. Okay, now I is the index of the first record with the given year and month. Okay. Now, then as long as I is less than n, and the record, this I, is having the same year and month, okay, then you take the card number. Okay, now from here you know what is the card number. Then the amount of that transaction will be the initial value, okay, for your total. Then for K from I plus 1 all the way up, as long as K is less than n, and now you want to check if that card, okay, match your current card. You use the compare function that compare year, month, and card. If it is the same year, month, and card, you accumulate the amount. Okay, so after you stop this for loop stops, okay, you compare total with your current results. If it has a larger value, you will replace your current result. Okay, then you update I to K and come back to the value and process the next card. Now when you stop, okay, you return the results record. Now this part of the while loop, the logic, is similar to one of the previous tutorials. Okay, that you have an array of numbers to find the longest segment, right? The structure is more or less the same. Okay, now the only part in these questions to test you is you should know what orders to use when you are doing the sorting. How to make use of B search to help you to locate a record that belongs to the given year and month, and you don't need to inspect records of other year and month. Okay. Find the first record. Do the accumulation. Compare the results. So if you have used Q sort and B search, okay, work out the assignments yourself. Then you will score some marks. But surprisingly, many students don't all mess up. Okay, with this. Okay, the usage of Q sort and B search.